So if we look at this one, the first thing we have to do is figure out what is the discount and the proceeds. So to find the discount, discount is basically our interest of our simple interest formula. So it's going to be $8,000 is our principal times a rate of 0.092 for the 9.2% times 120 over 360. So 8,000 times 0.092 times 120 over 360 gives us $245.33. Is that what you guys came up with for the discount, the interest? Okay. So that is our discount or the interest. So the proceeds are the original $8,000 face value minus the $245.33. Which is going to give us $7,754.67. That's our proceeds. So that is what we use to calculate the effective rate. Sorry, I blacked out there for a second. So to do the effective rate, our interest is $245.33. That'll equal our principal. We're going to use the 7754.67 times R, and our time is still 120 over 360. First thing we have to do is combine the $7,754.67 and the 120 over 360. So we're going to take 7754.67 times 120 divided by 360. Now we're going to get, well, in this case we got an exact number. It worked out just fine, so we don't have to keep it in our calculator. $2,584.89. So we're going to divide by $2,584.89. Now I'm going to keep it in my calculator anyway. I'm going to type in 245.33 divided by second answer to tell the calculator to use the previous answer. So I get 0.09491. We said try to go 5 decimal places at that point. We're going to change it into a percent. Moving it over 2 spots is going to make it 9.491%. I did not tell you where to round this off. Usually my math lab will tell you either to the 10th of a percent or 100th of a percent. Let's say I told you to go to 100th of a percent, so that would be 9.49%. So compared to the stated rate of 9.2, that is considerably higher. Now, one of the other things we went over last time that I want to make sure we review is that discounting a note. Remember, discounting a note is where you extend credit to someone, but before the note is due, you need the money. So you are going to, you're not necessarily selling the note, but you are selling the rights to collect the note to the bank and borrowing money from the bank based on them collecting that note. So let's do this. Let's say that you extend a 90-day, yep, right in there, note for $3,800 at 7.8% on May 28th. On July 1st, you discount the note to a bank at 9.5%. Find your proceeds. I'm going to give you guys a couple minutes. See if you can remember how to do this on your own, then we'll look it over. So what is step one? Find the maturity value of the original note. So we first, of course, have to find the interest. So $3,800 at 0.078 for the 7.8%. For 90 days, 90 over 360. So 3,800 times 0.078 times 90 over 360 is $74.10 is the interest. So that means the maturity value, 3,800 plus 74.10, is $3,874.10. That is the amount that the bank's discount is going to be based off of. Next, we need to find the discount period. Well, this is discounted on July 1st and made on May 28th. So if we look those up in our table, was it page 300? Sorry, 396, I should say. July 1st is day 182. May 28th is day 148. We subtract, that is 34 days. Is that our discount period? No. That's how many days have gone by. The discount period is the number of days left. So it's our 90-day period of the loan minus 34 gives us 56 days left. That is the discount period. So step 3 is to find the discount. So that's going to be the amount of the discount. It's going to be the principal. $3,874.10. That's the maturity value of the original note times 0.095. 9.5% was the bank's discount rate. And 56 over 360. I'm just going to double check that discount rate. Yep, 9.5. So 3874.1 times 0.095 times 56 over 360. $57.25. $57.25 is the bank's discount. So finally the proceeds, $3,874.10 minus $57.25. $3,816.85 is the proceeds. How many of you had that? How many of you were going there and just ran out of time? How many of you have no idea where that came from? Okay, at least no hands there. That's good. Okay, so that's a start. Well, this was all simple interest. None of the interest was added in until the very end of the note or when an action was taken on the note, like a partial payment, like we saw 2 weeks ago. We saw simple interest. Let's say we took out a $3,000 loan, we'll call it simple interest note. At 8% for 3 years. Well, simple interest, the amount paid back is going to be, the interest is going to be the 3,000 times 0.08 times 3, because 3 years is just 3. That's going to be $720 in interest. So the amount paid back is your 3,000 plus 720. $3,720 is your maturity value. But we discussed a little bit that banks would not generally extend a simple interest note for 3 years. Generally, anything over 6 months, they would do something called compound interest. Compound interest means they figure out the interest every set period and add it to the account whether an action has been taken or not. With simple interest, we only add in the interest when an action is taken, like a payment or a maturity date, the ending date. Well, compound interest, this problem might look like this. Let's say that this is a $3,000 note at 8% compounded quarterly for 3 years. What that means is every quarter of a year or every 3 months, the interest will be figured out and added to the balance of that note. And then the principal for the next quarter is going to be that principal plus interest. So you get interest on top of the interest, hence the term compounding. So let's look at this. Quarter 1, the interest will be $3,000 principal times 0.08 times a fourth of a year, a quarter of a year, which will come out to be $60 in interest. So that means 3,000 plus 60, we start out quarter 2 with $3,060 principal. So to find that interest, it's 3,060 times 0.08 times 1/4. Comes out to be $61.20 in interest. Notice we already have more interest because of the compounding, an extra $1.20. Did I do that right? Let me try that. Yep, it is $61.20. Just making sure. Now, how many times would I have to do this to get through 3 years? 12 times. Quarterly is 4 times a year. For 3 years, it would be 12 times. I don't want to do this 12 times. So let's take a look at how we can make this shorter. Well, when we did percent problems, we looked at increases. In this case, we have a beginning value each period. We're going to add interest to it, and then we're going to have an ending value each period. We have percents and we have dollars. On the percent side, the interest is actually right here. 0.08 times 1/4 is 0.02. In other words, 2% per quarter. Think about it. If 8% per year, divide that by 4 quarters a year, that's 2% per quarter. We started out, the beginning balance was 100%, so the ending balance, 100 plus 2, is 102% at the end of each quarter. Does that make sense? So, I could take my $3,000 and multiply by 1.02 for 102%, just making the 102 into a rate. Would give me 3,060. If I multiplied that by 1.02, I'd get $3,121.20, adding my interest on. How many times would I have to multiply that by that to get through 3 years? 12 times again. In math, we have a shortcut by multiplying by the same number over and over again. It's power. So this would be 3,000 times 1.02 to the power of 12. $3,804.73. Compare that to the $3,720 we had for simple interest. That's an extra $84.73. What do you think? Not so terrible? So let's take a look at this. There is a formula for compound interest. So you're going to start at the beginning is the present value. The end of the loan is the future value or the maturity value. But we're going to keep referring to them as present value and future value. The future value is equal to the present value times 1 plus my rate over x, where x is my number of periods in a year, to the power of t times x, where t is my number of years and x is my number of periods in a year. Now, a lot of times we're just going to combine this to be n, number of periods total. Let's look at an example. Find the future value of $7,300 invested at 3.8% compounded monthly for 6 years. So my future value equals, what's my present value? It's basically my principal, $7,300. Times 1 plus. My R is still my rate. So 3.8% as a rate is what? 0.038. Divided by X is the number of periods in a year. Well, this is compounded monthly, so that's how many periods in a year? 12. If it was quarterly, it'd be 4. Semi-annually, it would be 2, and so on. So divided by 12 to the power of 6 times 12. 6 years times 12 periods in a year. So I'm just going to replace this with 72. So let's see what that comes out to be. 7,300 times, parentheses, 1 plus 0.038 divided by 12, close parentheses, power of 72. 9166.12. $9,166.12 is my future value. Make sense? Find the future value of $2,800 invested at 5.1% compounded semi-annually for 4 years. So tell me how to set up my formula here. Future value is going to equal what? Present value, which is 2,800 times 1 plus My rate is 5.1%, so 0.051, divided by how many periods in a year? Semi-annually means how many times a year? Say two. Two. Twice a year, so 2 periods a year. To the power of how many years? 4 times 2 periods a year. In other words, to the power of 8. No, that won't do it. That'd be completely different. You have to combine the 4 and 2 to get a power of 8. Separately, it would give you nonsense. Yep. So 2,800 times 1 plus 0.051 divided by 2. Very good question, though, because some people do try that. To the power of 8. 34, 24, 86. Oops. So $3,424.86. What do you think? Not terrible? I want you guys to try something. Find the future value of $8,400 at 6.3% compounded quarterly for 9 years. See what you come up with. We'll discuss it in a minute. So, our future value will be 8,400 times 1 plus 6.3% is 0.063 divided by quarterly, so 4, to the power of 9 years, quarterly, 9 times 4 is 36. I'm just going to write that in there. So, 8,400 times, parentheses, 1 plus 0.063 divided by 4, close parentheses, power of 36. So 14,743.66. $14,743.66. How many of you had that? Just a few? That's not terrible. Anybody have any questions on how that works? Now, there is a table in the book that for special circumstances works well. This table is on page 459. And it is labeled the future value or compound amount of $1. What that is for every dollar invested, what the future value would be under the circumstances in the table. And what the table lists is on the top, it lists what's called a rate per period. The rate per period is basically this number right here, the interest, the percent divided by the number of periods in a year. We'll do some examples of that in a little bit. Then over here, this is the number of periods. That is basically this number right here. The number of years times the periods in a year. Then you follow those until you find a number in the table that's our factor. So let's look at the example. Find the future value of $7,000 at 10% compounded semi-annually for 7 years. Make sure that's on the table. Yes, it is. Good. So what we have here, rate per period we need to find. %, divided by how many periods are in a year? Semi-annually means 2 periods a year. So 5% is my rate per period. Number of periods. How many years? 7 years times how many periods in a year? Well, still 2. So that's 14 periods. So if we look up on our table on page 459, you find 5% on top. It's almost to the end. And you go down to 14 periods. We get a factor 1.97993. Did you guys see that one? Did I get the right one, or did my eyes cross me up? That's the right one. So what we're going to do is take our 7,000 times 1.97993. Gives us 13,859.51. That is the future value. Now let's compare that to what we would get if we did the formula, if we did our equation. 7,000 times 1 plus 0.10 divided by 2 to the power of 14. 7,000 times parentheses 1 plus 0.1 divided by 2 close parentheses power of 14. 13,859.52. A penny off. The reason for that is the formula is exact. This is the exact correct answer right here. The table in the book, this factor has to be rounded off to so many decimal places. They're only going 5 decimal places here. So that round off error is causing this to be off. The bigger this number is, of course, the further this is going to be off. So the table is approximate. Now when you do your homework in my math lab tends to use the table for almost everything. There's only a couple of problems in there where you have to use the formula because it doesn't fit in the table. Most of the examples we did up until this one, we could not have used the table because we had odd interest rates, 3.8% or 5.1%. It doesn't appear on that table on page 459. It only goes a half, 1, 1.5, 2, 2.5, 3. It doesn't go down to the 0.1% or anything like that. So in many cases, we have to use the formula because the percents don't work out nicely. So in my math lab, if you're doing the work and you use the formula to find the answer and you're off by a few cents, if on the homework, don't worry about it. You did okay. I'll fix it when I transfer it over to Blackboard. On the quiz, if it tells you you're wrong and you look back at it and you're just a few cents different, send me an email and I'll make sure I change the score on the quiz for you. I'll look it over and make sure that first of all, I want to make sure that that is what happened, is it's just the round off from using the formula instead of the table. And I'll change the quiz score for you. That is on page 459 in your textbook. You go up on top to 5%. And on the left side where it says 14, and you follow them down until they meet. 1.97993. Perfect. I'm going to have you guys try one with the table. Find the future value of $2,300 at 6% compounded quarterly. For 7 years. So use the table to find that. So let's double check. What's our rate per period going to be? 6% divided by quarterly would be 4. So 1.5% is our rate per period. So number of periods. 7 years times how many periods in a year? Well, still 4. So 28 periods. So 1.5 and 28 give us what? 1.51722. 2,300 times that is $34.89.61. How many of you had that? Or we're getting there. How many of you are just ran out of time? Okay. So that table, again, for certain values can be helpful. So I'm just going to give you one here, and I'll let you solve it by whatever method you want. Find the future value of $12,000 invested at 5.9% compounded monthly 5 years. So find that, we'll discuss it. So we'll set up the formula. The future value equals 12,000 times 1 plus 0.059 for the 5.9% divided by monthly is 12 times a year to the power of, well, 5 years times 12 times a year is 60. So the power of 60. $12,000 times 1 plus 0.059 divided by 12. Close, power 60. 16,105.87. So $16,105.87. What do you think? Not horrible? Okay, that looks like a good time to take our first break. It is 6:17. Let's come back at 6:27.